That's it. Just waiting to be live, which is already, I think. And yes, we are working. So let's go. Last time we did the thing, right? So we did the while loops, and now we are going to make the for loops. For that, yeah, that's it. We are just going to implement for loops. So let's start with lazy git, adding a new branch, so day 10, and that's it. So let's go. We can start by updating the thing. So int j equals 0 for, oh no, I don't need this. I can do int I equals 0, right? I is less than 10, and then I plus equals 1. Okay, so I'm already seeing a problem here. This is a variable declaration, and I can't parse it as an expression yet. This won't work, I think. This won't work. But yeah. So I can just say put di in here. So this should work. The plus equals may not. This has some problems, like we can omit this, right? We can omit this part, I think. Yeah. Okay, so let's try at least. Let's start with the parser. So I think that the parser will work fine. And I mean the tokenizer, the Lexer itself will work alright, unless it breaks. So let me knob here, invalid token as a primary, of course. So I need to check for the statement, so I need to go into parser, parse statement. Okay, and in here we have the else if that checks the keywords. So if equal for, so return parser parse for loop statement. Right, so this isn't implemented. Yes, you are correct. So parse result so we need to start by copying this and this. So we have this, failed to parse the for begin. We expect after the for keywords, and then we need to start parsing the conditions and whatever. So let me start by splitting here. Split, go into parser h and create the thing that we are going to use. So struct for loop statement. So this is so it needs the base as always, as it needs it. So we need a node that is the deco part, right? That's how it for loop C grammar. So you have the init clause, the count expression, and then the iteration expression. That's the official names. So is the init clause, the count expression, and the iteration expression, right? Yeah. Init clause, count expression, and iteration are all optional. If count expression is omitted, it is replaced with a non-zero integer constant. Loop statement is not optional, but it may be a no statement. What? C is kinda great, right? So in C you can place other things in here, like you increment n and print the n as well. It's great, isn't it? And if you don't want anything, you can just place a semicolon, which constructs a node statement. I thinking that. So in our case, I'm going to just say, brother, you need a block. So a node pointer block, which is the body. And that's it. So let's go and try to parse. So we need to parse the init clause, which is a declaration in most cases, but it can be null. So I can start by saying, I can close this one, but I can also say this first, for loop statements. So close this. So we need to parse things, right? So I can start by saying parse result condition, init clause, right? And I'm evaluating it to evaluate result. If the next token is a semicolon, then this just returns nil. We don't change it. So if print, so if parser get token p type is semicolon, doesn't equal a semicolon, I mean, then we say init clause equals parser parse expression p, and we do the normal check. If it's not okay, we just return invalid result. Then again, if the parser get token P, the type does not equal to the semicolon, then we can say, I need the thing as well, so close, this is the cont exp, which is a value response as well, so cont exp parser parse expression if con exp, okay, with this invalid result. So same thing in here. And then we need to parse the iteration part. So in here, oh right, so I need to expect, if not expect P to be the semicolon, we say int f expected after init clause same here. Print f, so we expect a semicolon after the condition expression. Okay, so now we need to check for iteration one, right? So iter expression, so we expect we parser get parse, no, we get token P, that doesn't equal to tt close paren, we say that iter expression is a parse expression, same size, if not iter expression, okay, we return invalid results, then we expect P to be a tt close paren, if not, in f we say expect after iteration expression. So we return invalid, and now we have all the steps. No, we need also the block, the body. So body equals parse statement P. If the body is not okay, we return right. Right. So we can now, we have the body, we just need to construct the thing. So this will return a parse success node, and we can construct a node. So node, we use tempo walk, So the node type is empty for statement. Then we set the location. Then we construct the for loop statement. The base itself is node. The init clause is init clause node. Body, no body, count expression is init count expression node. I don't think I called it this, right? Yeah. So we have the body. And then at the end we say that node for loop statement is statements. But we need to go there first. So we need to go into parser h, go into union, which is the only one here, and do for loop statements for loop statements. So we have it. We constructed the AST for the for loop. I don't know if it's going to work, but it's constructed. So we also need to print it, empty for loop statement. So what we do, okay, so I need to check some things first. In this case, they can be null, so I need to check first. So if for loop statement the init clause does not equal to null, we print f, we parse nodes, we parse the for loop statement init clause, right? That's it. So you can just copy this and paste it and paste it. So this one is the condition expression. So this one is the iteration expression, and at the end we just parse the block itself, the body, and that's it. So expected name, yeah, things, normal things. So if we do this, it's going to say in the IR, of course, ir.c. If the case is empty for loop statement, we break, and I'm going to just assert false and implement. Okay, so it failed. expected that after init equals okay, so let's go into the parser. Let's go first in the example. I'm pretty much sure that the problem is this thing here. Alright, so I can do this and it doesn't work. Invalid token as a primary, because it's this part here. So this isn't handled as a single token in actual things. So I need to add a special token for plus equals in the vexer, right? So vexer x and something like equals, what is the plus? If so I need to check if the token followed. So if contents at cursor plus 1 equals this, else do this, right? So in this case I construct the token normally, me being sv from parts contents plus cursor 2, right, is the size, yeah. So then the type being tt plus equal, the location being file name, we don't set it yet, the column is column, the row is row, that's it. Then we append into the vexer tokens token, and the other thing is that the cursor is advanced by 2 instead, and the column is advanced by 2 as well. Now we need to go into the vexer h, tt plus equal, right? So we can do a replace on this one, and it should give us a plus equal. There it is. So it's working. Let me go into execute to save that already. So the vexer parts, so add plus equal, and then it says that expected after iteration expression. Wait, you break in there. So you parsed this. You parsed this as an expression, right? Or not? So it's not the by not. I don't know how this should be assigned as a assignment. We're going to person assign by not. Yeah. So the equal or the case tt plus equal, they work the same. Right, so and in here I need to also add token type does not equal tt plus equal. So fuck. So okay, so it worked. Where is it? So for loop statement, which has a binary expression checking if I is less than 10, and then has a binary expression adding 1 to I. So the for loop itself, it's being constructed, the st node is being constructed, but it is not working if we instantiate the actual thing in here. So can I also break this? So as a for loop we don't need that, and I can also make this, so I can make yeah, it works. So we can create a for loop like an empty one. So in here the int I equals 0, this one is breaking, right? So that is probably because parse expression it parses a first expression. This one. So it parses a primary. Right. So it parses a primary, and then which so it parses a primary. So I can split in here. Do I have any test thing? No. So 30xt. So I can explain it here. So int I equals 0. If it's parsed as an expression, it will become an ident. Then it will check if the next token in the line is a paren for function calls. If not, it will try to parse the right hand side, which will check if it's a operation, a binop. If it's not a binop, it then returns ident. So it returns ident, and then it checks equals. So a way to fix it. So this parses function calls, but it checks only for the next one. In the default one I break, but I'm going to do first this. So if I'm going to pick, right? So the pick token. If pick parser pick get token offset. So parser get token offset. So we take the parser and the offset is 2, right? So if we couldn't get it, so I provide the pick token. If it didn't work, I just return invalid. So I think this one, yeah, it just returns. So int f couldn't pick. we need better label followed by a declaration. Okay, so I need to do this. So the token, so I check if pick type is equals to holy fucking crap. So I need to check if it's an equal, right? If it's an equal as break. Alright, so if it's an equal, we need to return parse result is LHS is parse var decal statement, but it how to undeclared function. Yeah, this is kinda not working. This is kinda not working. That's a problem. I mean, let's I can remove this. So parser parse this. So in here, so parser parse expression. And we go into here, and then it tries to parse a variable decal statement, which at the end it expects a semicolon. I have a workaround for that. So yeah, if LHS LHS it needs to be res. So this is res. Oh, it's even worse. It can't be. Cannot be that. This expression, this part is so fucking annoying to parse, because it's a variable itself. This can be a variable declaration expression, but in our parser, variables are only statements, they aren't expressions. So for now, what I'm going to do is the following. I'm going to remove all the changes that I did to parse expression. right? So in this one I'm going to save it. So it's going to complain about it, so I'm going to here, I'm going to say only this: I is less than 10 and I plus equals 1, because it's a valid one. I'm going to place a fix me here. It doesn't support a var decal in init clause. Something like that. Right, so oh, of course I don't have fucking comments. Oh my god. Let's add comments really quickly, because it's fucking annoying. So if case is this, right? If it's this, we break and we check if the next one is that as well. If contents at cursor plus 1 is actually as well this, we say for while cursor, so while contents at at cursor does not equal a new line, we do cursor plus equals 1 and call plus equals 1, else we assert unreachable. False, probably unreachable. Okay, so it worked, right? So we have the for loop here with the binary expression, which is an assignment, then checking if it's less, and then the iteration. So let's make it work in the IR. Let's make it work. So also let me go into EasyGit. See git comments like right. So we have that. We can go into nvim, right, and go into the IR. So to make it work, we need to generate the first init clause. So we just say IR generate for node for loop statement. So let me actually for loop statement pointer for it's the init clause into ops and into strings, right? I can also, yeah, it's printing fuck you this. So at the end it has a label, which is the end label, right, that we jump to probably, yeah, around here. Then we push int 0 and we start at 5. and 5 is I, so it's correct. Okay, so the first part is correct. So now we need to it's mostly this, right? It's mostly this, because we have a label for the condition to check the condition. So int count index is ops count. Yeah, it's exactly this, but it's the same. So let me just replace as while with for. So this part here, we can just say for loop statement count expression. For index is not used, so I'm gonna just void it for now. So this is our init part. We saved 0 in I, then we created a label and we loaded I and checked less than. Which is correct. Then we need to create a jump condition. That will jump to the end label, which is this part. So the count jump is this part. Right, so it jumps so it creates in here, what is it? So we load it, we check, and we jump to 33 if it's false. Yes, so it's working. Else we continue. So then we also need to make it so we have a jump that goes into while. So this is the part that it goes back to the beginning, right? So it generates the body, creates a condition that goes into, so this one is fucked, so it goes into for index. But this one needs to be appended after we do for loop statement iteration expression, right? So unimplemented operand. Yes, that's right. So all of this is expecting that we don't provide new expressions, right? So oh, okay, so it's in here, not in there. So we can copy these parts. Say else if it's plus equal, so this is a problem. That's a problem, right? So that's a problem. So it should generate both operands. Of course, it's faulted. So in here, what is it? It is jump if into 38. Alright, so that's it. So in here, when we have loads, and we call, then we have a load, which was 5. Then that's the problem. We set the operand to 1, but we don't need that. So after this, we create op plus 1. So we do op equals type equals op plus, and the operand is nothing, right? Yeah, we can set it to none, to 0. So with the a appends into the ops the op, then we create a store. We just create a star. I mean, C is kinda dumb, right? So it says it pushes evolves 5. It votes I, then it pushes int and there's a buzz, then it stores. But store requires the stack to have values. store requires you to have even store requires two values on the stack: the value to be stored, the store, so the x, and the location. So it stores x into lock, and we can, yeah, because like it's kind of bad. But plus equals always as a L value of an identifier, as a thing that can be loadable, right? I can assume that, because you can't assign to something that doesn't exist. So I can just redo that part, so I can just regenerate the left hand side, right? So I can do bin expression LHS, right? Degenerates a node, so I can redo this hack. That's the thing. I can redo this shice. But instead of just doing that, I need to also do this. And C being C, of course. Right. Yes, it worked. It worked. So what happened is that we jump to 40, which is the end of the loop, right? If the condition is false, this is the condition part. We will push and check, then jump if checks if it's a 1 and it goes to true. If it's false, it goes to the number, right? So 40. Then it loads I and calls it to put D. Then it loads again and pushes, because load itself pushes the value that it loads into the stack, and then it pushes an int as a 1 and then makes a plus. Then it doesn't appear here, but we place a load in here, then we remove it and save its location to store at. So in theory, what should we do is create an instruction that loads its address to the stack but doesn't load the value itself. So it's more like a load pointer, or get, more like a get pointer. But yeah, so then we jump to 28, which goes here, which is the label for the loop. Then we do again, and we do that until we get to the end. So it's working. But yeah, that required another hack, and we are not getting really the things that we care. Like we can check, you can say int I is 0, right, which saves the value, and then let me check if it works. Yeah, it's working. Then we can, just to be sure that it works, we can print it, and it prints 0. Then we can do a empty loop, right? So we can do this, right? And we can say if I is less than 10, we can say I plus equals 1. I mean, I can say this, I is less than 10, because I don't have a way to break from the actual thing, so this should break its segfault in some way, which it does, because this part is null and this part is null as well, right? So we need to check for that before we generate the IR for it. So into IR we can say, what is it? So NT for loop statement. We generate the init clause. So if for loop statement init clause does not equal to null, we generate it. Then here is the condition expression. Oh right, but now the jump if. I'm thinking, okay, so should I create a jump if there is no condition in there, right? But yeah, I'm going to just for loop statement condition does not equal to null, and I'll do this. And again, for the iteration part, if for loop statement iteration expression is not equal to null, we save it. So it should work. It didn't work. So the control flow, right? Oh, it worked, but I never printed the number, I think, to TI, and then for now I'm going to say that I won't do this. I'm going to check for 20. Oh, right, because yeah, so it printed 0 to 9, then 10 to 19, because it was that. So it works fine. We accomplished the actual thing. So we implemented the for loop with the various statements. We added fix me. We added comments very quickly because it's useful. That's it. So let me go into LazyKit so we can start. So here, update control flow example with for loop, and in here we added the for loop, right? So I mean, so there is a thing in here. So this part is parse plus equal as lineup my bin expression, and this part here is add for a node for add ast for implement for oops generate IR for whoop IR. Right, I think that's it. So this can be discarded, and I think that's it. Okay, so let me check a thing here. So it's printing stuff. Let me go into so that's in IR, right? So at ends I need to set this to 0, and it works. So I can just go execute again. So let me git commit, so I can git add ir.c, git commit amends, and fk, can close this. Yes, I can just close, not save. Basic git, so this one I can discard, and that one it does that. So I can just come in here and push into date 10. Let's go here, pull requests. We have a new one, date 10. So implement comments. So we added new control flow, which is the for stuff, and that's it. We just did that. We create a pull request. Oh, we also did this, so we need to add it. So add new assign token plus equals, so update merge requests. So 10, fuck's sake, my fat fingers, and we merge. That's it.